All right. All right. Sorry, off to a slow start. Well, 2 minutes late, but good morning. My name is Charles. I've been here a couple times presenting. Man, I hate when I share my screen, my Zoom goes away. So I'll try to figure out how to get the chat up so I can watch the chat. Yeah, there, I think I got it now. Can't see your smiling faces, but I will live. So let's get rolling. I think I got everything. So if somebody pops something in the meeting chat, I can catch it. And I'm presenting on another screen, so my video's on, so I'm not looking straight at it. But that's just because two pages are nice when you're or two screens are nice when you have a couple things to share. Yeah, I got that. All right. This is our agenda as it always is. We're gonna follow it through. We'll go through the welcome. Welcome. We'll go through some club business. We're going to talk about events that are notable, some future presentations and what we're doing today, Robothon committee updates. We'll do the round room, virtual room, of course, because we're on Zoom. And the ask of course, is to save your sharing, save your sharing for there. Anything else, we'll do a break, and then we have a pretty solid presentation today and a conclusion. And the ask here is, if you have any recommendations for additions, changes, or anything like that to the format of this meeting, please share them. There is an email and like 2 slides for you to share if you don't remember the email address for. Well, it goes to Steve, I think, but anyways, we'll move along. As always, for just the business portion of this meeting, please mute your mic unless you're actively sharing or you have something important to add. Use the Zoom chat to ask questions, make comments, post links, or any other information you wish to share during the meeting. I think Robert's already started adding some stuff, which is great. Thanks, Robert. But anything, drop it in the chat. We will copy those links off, and those get shared later, I think, in the YouTube video. I'm not sure I don't remember if it goes to the comments, but they get shared anyways. Normal club business, we will continue to present this online only via Zoom. You're there, so you kind of figured that out. It's presented by Lloyd, usually, Steve, me, or Donna, or others at this point, anybody. But somebody will host this meeting online via Zoom. Steve will continue to schedule the presenters and update the website every month so that it stays current. If you have any questions, comments, suggestions, etc., especially the complaints, go to, send them to seattleroboticsociety@gmail.com. I kind of like that they decided to move this off to the website. I think it's great. I definitely like websites as resources myself, but if you want to look at the list of local makerspaces, visit the SRS homepage, select resources, and select makerspaces. You can also go to makerspaces.make.co to view a list, and I think they even have a map, if I remember correctly, that you can go zoom in. Why is this here? Well, sometimes it's nice to find a place to go in person to build stuff, collaborate with people, use tools. I mean, most of the maker spaces have some sort of tools, electronics, mechatronics, metal shops, wood shops, whatever. And it's just a nice place if you live in an apartment or don't have access to tools yourself. So look at those. Events coming up. Of course, we have an robotics events website. We put events on the SRS page as well and the robothon.org site. There's also some meetings at the Sunoco Makerspace, which is in South Everett, if you're looking for in-person. Those are strategically placed in an alternate Saturday. Those are the first Saturdays. This meeting is the third Saturday. So if you have any suggestions about past events or events that we should be watching, again, either dump them in the chat. Looks like Robert's already doing a good job of that. And yeah, dump them in the chat, or and of course, send them out to seattleroboticsociety@gmail.com so that we can get them posted. Thanks for putting in that Washington State Fair one, Robert. It's a pretty good one. There's also the Northwest Model Hobby Expo. That's that one's in Monroe every year. Sometimes they do it twice. I think it's in April this year. So I don't have that link, but I'll dig it up later and drop it in there. For the Robothon committee, the next Robothon event is not in 2024, it's in 2025. I should have caught that and edited that. That's my bad. We should get some more photos up here so we can see Bob's smiling face and Doug and Rob and John. I might have missed one of the Robothon meetings. It's totally possible, but it says here the spring event at Sunny Ridge. I'm pretty sure it was going to be at the first facility in Kent. So maybe don't take that with a grain of salt until I know otherwise.
Chaz, sorry to interject, but it's Sunny Crest. It's Sunny Crest School.
It's also Sunny Crest.
Yeah, Sunny Crest.
Don't go to Sunny Ridge. Nobody even knows where Sunny Ridge is.
Sunny Ridge. Yeah, no.
Yeah. So so I think the spring event, which isn't set in stone, is at the first facility in Kent, where we had it last year. And then in fall, we're going to continue because it's a great venue, fall 2025 event, probably around the same time of year as we had the last one. It's at Sunny Crest, which is an elementary school and kind of the intersection of SeaTac, Kent, Des Moines. I forget which one it's officially in, but that area anyways. Details to follow the website robothon.org. That's where you can get the event details, sign up, and all the event rules and whatnot. So do you have anything else to add, Donna, before I move on?
No, other than that, also at robothon.org, in addition to all of our announcements related to contests and events, that type of thing, which is primarily advertised on robothon.org and not on seattlerobotics.org. I also invite you to join the Robothon email list, in addition to the groups.io email list that is associated directly with the SRS. And the reason why I'm suggesting the Robothon list is because I manage that, by the way, is because of the fact that way you're in the know right away without having to worry about going back and forth to the webpage all the time to find out about updates on events and all that kind of stuff. So on the homepage of robothon.org, there's a big button there to invite for the email list. So I wanted to throw that in.
Yeah, I appreciate that. Thank you. Absolutely. The next slide we have here is a new slide. It's a new, Seattle Robotics Society related meetup group. It was just launched. I saw if you're on Meetup, it's kind of a social gathering platform for places, things to do. You can kind of trend and follow things that interest you. And because I have an interest in robotics and electronics, I've already seen this pop up on my Meetup, but it's called Build It with Arduino. It's a new Meetup group. The link's right there. It's meetup.com/builditwitharduino. There's a nice handy QR code that you can take your phone right now if you're not watching on your phone, and look at it in a little photo viewer, and I'll pop up a link to go visit this meetup. You will have to sign up to follow and get the updates, but it's they don't spam you other than giving you suggestions for related groups. Your group organizer and host for the events is our own Donna Smith. I encourage you to join the group today. Come find out what it's all about. I will tell you that it's a great entry level if you don't have experience with electronics, or maybe just electronics but not Arduinos, or even if you know Arduinos and you're looking to help or fine-tune your skills. It's one thing to say I know how to use Arduinos and blink lights, but knowing best practices and using header files and all sorts of stuff like that, there's always more to learn. The first meeting is Saturday, February 22nd at 1 p.m. So next month. I encourage you to send that off to anybody that might find value in it. And I guess since you're also hosting this one, did I miss anything, Donna?
No, other than that, I just wanted to add a little context of why I had the inception of creating this group. Is the idea to directly, even though it's not quote unquote associated, this group is not associated directly with the SRS. My goal here is to help us, is to give us another outlet, another learning, another build and experimentation outlet besides what we have here within the SRS, to experiment more, to be able to build more robots, be able to compete more in our contests. That's the overall goal of this particular Arduino group. So I'm looking forward to hosting. I'll be the primary host and organizer for this group. And I'm looking forward to taking it in all sorts of great directions with all of your help and participation. So again, as Chaz was saying, please join the group and plan on attending every and all events that you possibly can.
Great, thank you, Don. I saw your mention there, James, with the other meetup. Just a note, Steve, if you're watching this video, hopefully please take a look at James Newton's note. There's a problem with the link for the YouTube on the meetup. Thanks, James.
Happy to help.
Yeah. We're actively looking for presenters. I know there was a couple out there that had a hard time getting a hold of, but as always, we're looking for online presenters. It can be anywhere, right? I mean, there's a number of people. I think James is down in San Diego, and Bob's up in Canada, etc. So we understand international presenters. We might need to alter our meeting time for their time zone. But if you have any suggestions, maybe reach out to them if you haven't already. Include the SRS email address in the carbon copy line of the correspondence so that we can help take over the conversation for scheduling purposes. Or if reaching out is your thing and you're interested in running a presentation of yourself, it doesn't necessarily have to be the full hour, but consider presenting on one of your projects. It doesn't have to be a robot in the traditional sense. It could be like a CNC machine or some tooling to build robots or process whatever. You could also lead a facilitated topic, some discussion about something related to robotics. Robotics is mechatronics, CAD, potentially programming, etc. Electronics. Lead a discussion about interesting videos. So if you got a collection of YouTube videos, I think we always have a handful of those for sure. You can also do that to help out. So please consider doing that. Reach out to Steve or email seattleroboticsociety@gmail.com. This is just a list of open discussion forum ideas. Certainly take and put one of these in your pocket if you're interested in talking about them. We'll talk about these, or we'll open it up for discussion in just a couple of minutes here. So I'm not going to read all those to you. I think I'll give you just enough time to read them to see if there's something interesting there that you want to talk about. And of course, if you think something else belongs on this list, again, reach out to Steve or email seattleroboticsociety@gmail.com. This is our 2025 presentation calendar, I'll call it. I don't know what to plan. I guess it's a plan. We're hoping for this to happen, but this is what's scheduled. Today, we're going to do the Builders Roundtable presentations. I'll talk about that here very shortly. Next month, we're going to do, it's a Federal Way FTC robotics team. They're going to do a presentation on their robot. In March, it's tentative, but there's a SLU student robotics project. I don't know much about it. I guess it's a presentation against somebody's robotics project for SLU. John Davis is returning for more on AI, which is great. If you didn't see the last one in last June, go check out the YouTube on that. He had an original presentation he did last June, and there's some more. And then from there on, May on, there's nothing but open spots. So obviously we need a couple more presenters to put in there. I think Steve's got his work cut out for him. As always, we do a post-meeting general robotics discussion. That's after the presentation. So if you're in the Pacific time zone, it's 10 something right now, 10:17. We're going to do some open chat, like in the agenda said, then we're going to do our talking topic. This is generally around noon. We turn off the recording for that, but if somebody wants to stick around, that's great. I cannot stick around today. I got a lot going on today. a lot of home stuff to do for some reason. But I can turn the host over to somebody if they want to stick around and have a chat. Presentation coming up later, close to the top of the next hour. We're going to do a robot builders panel that includes Donna, John, Bob, and me. Me. One of those. This is an interesting topic, a topic Donna, I think, recommended, and it's a great topic of discussing our robots process, something around the robots that we built last year and competed with, or potentially wanted to compete with, maybe in some cases, and just lessons learned or what were our successes. It's really kind of up to the presenter. The litmus test is they're around like 10 to 15 minutes so far, so that they're just going to be 4 different discussions. We'll probably run them in that order, for no better reason than that's what it shows on the screen. I didn't, or whoever wants to go first, I really don't care. It doesn't much matter to me. But Bob is not here today, but he did send me, took the effort to go and record the whole thing so that he could have his. So I have a recording of that. Yeah, actually, maybe if you guys don't mind, I'll do Bob because I'm already sharing the screen and I've already got my audio shared. So maybe I'll do Bob first and we'll go to Donna if you guys don't mind. So, quick review for next month, same Zoom channel, same Zoom back time, etc. The meetings are posted to the website, YouTube, fairly quickly. I mean, it's a little bit of manual work there, but they get done pretty quickly. We're always looking for help finding presenters. Send your feedback, and of course, thanks for continuing to share in the chat. You guys are the chattiest bunch I've ever met in my entire life in the chat. I love it. It's great. I can keep it up. And then we're into a round of the room. So he's got a bunch of videos here. If we're just having some pregnant pauses and nobody wants to talk, I've got like one little thing to share maybe. But I'll just start by turning it over to the group here and seeing if anybody has something they want to share or bring up, discuss, have a question about. Hey, James.
I have a couple of things to share if it's time to go.
Yeah, it's time.
So the first thing is there's some sad news. The Paddington Dynamics group that I've put many years of my life into has been defunded by the multinational that we were bought by a few years back. We designed the robot they wanted, but now that once it was designed, that turned out they didn't have the oomph to actually produce it. They had to, save money, and we were part of the money they saved. So we've all been let go. And I put a link to my profile in the chat if somebody knows of a job or just wants to take a look at my resume. It's linked from there. As a Google Doc, you can comment on it and tell me what I should be looking for or what I've done wrong with my resume or whatever. The other sad news is that the IP lawyers just completely screwed up our attempt to get a VC to fund purchasing that IP. So those last 4 years of work are just gone. I'm sure you guys have all had your sadness with, work that was done, not open source, that can't see the light of day. But that's the worst one that's happened to me. So that was pretty bitter. The open source robots from before that are, still available, like the old Dexter robots are, still there. They can be 3D printed. And I've actually been working with a couple of people on printing those, which has been kind of cool. The good news is that it's given me the time to work on um, the encoder. Previously, there's been this misconception that encoder needed to be paired with an FPGA, that it wasn't any good unless you had an FPGA involved. And that's simply not the case. And I've actually demonstrated that now and made it public, link in the chat. So that's with just a Pi Pico and some laser cut parts, a little bit of electronics, really simple electronics. That's 100,000 clicks per revolution. And it's quite good, actually. And I am now expanding that into a full-on servo system. I probably don't have the time to describe this completely. I'll do it later. But my thesis, and I'm pretty sure that this is true, is that if you have a PID controller, the faster you can respond, the less the I and the D terms matter. The P term matters more, of course. I mean, the P term is important, but the I and the D terms matter less and less and less the faster your control loop can respond. But there's two sources of delay in PID control loops. The first version, which everybody thinks about, is just the time that it takes to take a reading and then like send a signal to the motor to tell it to move in a different direction. So like this computational sort of delay. But there's another delay, which is the low resolution of the shaft encoder. So if you think about an encoder, let's say that you had one that only had 360 CPR. So it only would click once every degree. And at startup, let's just say that you want the thing to be at 0, and it's currently reading 0, but it's just clockwise of the 0 position, right? And then something pushes on it and starts pushing it towards the 1 degree mark. The control system gets no information that there's been an outside disturbance until it passes the 1 degree mark. And that represents a time delay as well as a positional error. So having a super high resolution, super high CPR encoder, it's not about the precision. It's about the instantaneous response as soon as there's any kind of a disturbance, or instantaneous response as you're approaching your goal position. So I think that the kind of really amazing control that we get out of the robot arm with nothing more than just it's a positional P only PID controller. So using the stepper motor and using the super high resolution encoder, the arm doesn't oscillate. And because the control system is so simple, we don't have to try to compensate for things like load, mass, friction, all the rest of that, which you can't in a robotic arm because the load's constantly changing with kinematics and with what you've picked up. So I'm trying to demonstrate that, and I'm making progress on that. Happy to talk to anybody or collaborate with anybody who's interested. Thank you for listening to my TED Talk, and I will now turn it back over.
Oh, Chris, how's it going?
Good. I wanted to confirm a thing. So you had said in email that the presentation that the students were going to provide next month needed really to be mostly just Q&A. And so that was the guidance I gave the students. And so they may or may not be prepared to do much of a presentation, but they're really expecting you all to have questions for them about the experience of being on an FTC team and what the robot is and does and what FTC is and does and all that sort of stuff. So hopefully that's still okay.
Yeah, absolutely.
Okay. Then the second question I had was with respect to the spring Robothon event. I'm looking at the site and I don't see a date on it yet. Has that date not been decided?
It has not been. I think we're still negotiating. We meet at usually in spring. Well, we decided we were going to meet at the first building in Kent, and sometimes we have to work around them, right? Because the first comes first, because we're using their space. I don't think we've gotten a date firm from them that we can use it yet, but it should be coming pretty soon. I saw some emails going back and forth on that one. But you know, they're in the thick of it right now, right? They just got, I think they're doing finals or semifinals right now, so it's on the FLL stuff. So I think hopefully they can get a little bit more bandwidth and you know we could finish up our discussions and get our time locked in.
Okay, great, thanks.
Yeah, no, thank you. Because you mentioned it, James, I just shared a link in there, and there was a company that one of my friends sent me a link to. It's you know, co.bot, so co.bot, and it's for a company Cobot. They were just, I guess his son has been working there for a couple of years. He was an engineering student. And they just got funded. They have a cool looking robot. If you guys decide to go check it out, it's kind of an open platform in a sense, but it looks like it has some very targeted non-military. And I think they actually boast that it's, you know, a robot that's not built for the military. For whatever reason, maybe that's their marketing gimmick. I'm not sure. But but it's a cool looking robot. It looks pretty fine-tuned. They are funded and they are hiring. So I know it's West Coast. So I don't know if that works for everybody. There's actually some jobs up here in Seattle. I looked, I don't know if he was trying to get me out of work or he didn't like me anymore. He's trying to like, hey, go work for these guys. I don't have to see anymore. But they're look like they're mainly most of their staff is in California. I imagine with most companies these days, remote working is somewhat acceptable as long as you don't mind traveling here and there. But work for a company out in Milwaukee. I would never ever live in Milwaukee. But yeah, and then to another thing you had mentioned, James, I absolutely can't stand, and I won't say that I'm exact. I am speaking from experience. I hate when companies that I know and love buy some piece of IP or some sort of company, and then I don't know, like they had a wild idea and they needed this company for its IP or the amount of development they've already done, or maybe just a couple people, and then they destroy it. Like they just absolutely kill it off. And not even like they go and reuse the components. Like they made a mistake, it was the wrong direction, and then just all that intellectual property is gone. Nobody decides to sell it off or spin it or anything. They decide to they shrunk it down to nothing, and that happened kind of recently to some of my friends up here for the company I work for, and I'm just like, oh, why? You know, like what a waste of money.
What drives me nuts about this is it's first off exactly what you said, you know, just what a waste. But it was also like not like we don't see any value in this and therefore we're going to trash it. It was we see great value in this and therefore we're going to bury it so that no other company can have it.
Yeah. Yeah, that's the worst of the worst for sure. Like that, I don't know, that seems like just anti-civilization or something. I don't know what to even call it. It's just, yeah, terrible human stuff for sure. So I feel your pain. And the thing that I, you know, like I have some friends that were affected, you know, and they got let go. But like I know they're hardworking people. They had a passion. They had a product that could have gone somewhere had somebody not messed with them, right? And I get like you when you're in these smaller companies, you sell because you're like, hey, we want to make this actually happen so we can go get the funding. But then to, you know, have this, you know, make a corporation just chuck it in the round file.
That's why I'm really focused right now, and I'm kind of not spending all my time looking for work, but just, you know, living off my savings a little bit and working on open sourcing as much of the stuff that was there before we were acquired, right? So like this encoder, this amazing design for an encoder was open source years ago, and I'm just showing that it can be used with an embedded controller because we've always used it with an FPGA, and I'm super excited about the results that I'm getting from it, and I had this really neat thought the other day that it's actually about, you know, the time delay. It makes the time delay go away because the instant that thing moves, you get an indication of it. So I like the idea of like building things up in the open source so that they can't be stolen. And yes, you don't make money on that necessarily, but you know, part of my hope is also that it's like, you know, hey, look at this guy who's doing this thing, and you know, you really ought to hire him, or else he's going to make it possible for everybody to build robots, and we wouldn't want that. So hurry up and hire him and shut him up. No, that's a very cynical take on it.
It's like it's okay to be a little cynical right now. I mean, but you can look at like things like look at Red Hat, right? And this is my spin on it. When you have a company like Red Hat that builds a nice, you know, Linux operating system, and they make money now because the companies that want to use Red Hat want support along with that, right? Like, yeah, you can go and, you know, install Ubuntu for free and use it all you want, but at the end of the day, when you have a whatever number of developers you have and they're building a solution around your open source platform, they want support, and so they'll pay for that support. So I think that's the way around that, right? Of course, if you decide to do some other licensing or something, but I hear you.
Yeah, that's great, and I think the work that's really coming up, well, with the new AI control systems that are coming out, I hope you guys have seen, for example, Unitree Awakenings video. If you haven't, I think actually Steve showed that at the last meeting. If you haven't seen that, you really ought to see it. And then the Genesis Sim, which is how they got that Unitree robot to move that way. They were collaborators on that particular system. I think there's going to be a lot of work for integrators, for people who understand enough about robots to be able to get them in place and start collecting training data for a specific company's needs, and you know, just like working with integrating the robot into a particular application. So that's kind of adjacent to the sort of support work that you were talking about, Chaz.
Yep. Yeah.
But I think there's going to be a lot more jobs like that, because this whole thing with the Genesis Sim and what Unitree and Aloha Robotics is the other one. Aloha Robotics really has a good set of videos that really demonstrate exactly what it is that can happen with that. It's amazing.
Great. Okay. Maybe drop a link in the chat if you don't mind, so I can look at it later.
Yeah, I was saying that, and I was going, "Oh, he's going to ask me to put a link in, isn't he?"
You know, I'm going to. Yeah, for sure. All right. Anybody else have something that they want to share? Questions, etc. Donna, I know that we all have like whatever it is, 10, 15-minute videos. That's an hour, but that leaves no time for questions. So I wonder if you're against starting a little bit early on those, just so that there's plenty of time in between for questions. Donna's working on something without her headphones, so she can't hear me. That's fair.
I'm okay.
Well,
with
I'll
that.
ask John. Are you okay with that? Okay, cool, John. Thank you. I'll tell you what, I'm going to, unless somebody has something else to add, I'm gonna say like 5-minute break, you know, like go refill your coffee, go use a restroom or whatever. We'll come back at, you know, well, 4 minutes now or whatever. And then I'm gonna start Bob Cook's presentation. It's a video, so we can't ask him any questions, but you know, maybe you or I, John, can fill in some questions just from all the questions we asked him last spring. But maybe just 5-minute break or so, somewhere in there, and we'll come right back. And I do not have a way to do a timer on this, so I'll just put up a note maybe and share my screen. So see you in 5 minutes. Come on, let's open up. You can still talk to if you have other things you want to talk about.
Hey, I'm writing up a huge post about this Aloha robotics thing, but this is I just want to clarify again that this is an absolutely fundamental change in the way that robots get used. It's absolutely massive. It's shaken up the industry, top to bottom. It is like I've seen such a huge change in like the direction that companies are going as a result of this one um, release.
Yeah, I'm new here, but I just wanted to completely second that. I saw the Aloha research coming out of Stanford. I'm part of the Portland Robotics Society. I made a little presentation for them, which maybe we can talk about. I could give here in this group as well. But it's all about the Aloha robot and how cool it is. They're using transformer neural networks to do motion planning for robotics. It's the same technology that's behind ChatGPT, but instead of predicting sequences of language tokens, they predict sequences of motion. And so it's very powerful. It's really cool. I started a company to try to take advantage of this wave. We're just getting off the ground. We don't have money yet, but it's really exciting. So you should check it out.
Joseph, you need good robotics engineers at your new company. Hit me up.
I will. Yeah, thank you.
Yeah, so I just posted a link to it. I really recommend checking out that Mobile Aloha GitHub IO. And then the other one is the Genesis SEM, which I will look up now.
I'm gonna do this real quick. Yeah, if you don't mind, Joseph, or whatever you go by, hi, um, uh, emailing us, or you can email me if you didn't catch the Seattle Robotics Society at gmail.com email address. Mine's just, I can put mine in here. Actually, I'll put his in there. We are always looking for people to put on presentations, or those are always big winners. So I think it's that, but if that fails, no chance at nocodemakers.org, and I'll forward it to you.
Okay. Yeah, thank you. I will send an
No,
email.
thank you. Yeah, absolutely. Thank you so much. Appreciate that. I'll be right back in just a second. I am going to use the restroom.
So one of the keys with these robot controlled neural networks is that neural networks in general need massive numbers of training examples, which is how ChatGPT ended up happening, because it had the entire internet. So you could give it like all of these examples that were already in digital format, already ready to go, right? You just scrape the internet and shove it into the neural network, and away you go. But those didn't really exist either for self-driving cars, and they certainly don't exist for robots, although they are starting to be released now. And what you need there is basically you need like a picture that shows what the camera is going to see, and then a text prompt indicating what the robot should be doing, and then sort of a recording of what position the arm or arms of the robot should be moving to, given that view and that text prompt. And so these training data sets didn't exist, and you'll see like in the Aloha thing, they're doing this teleoperation where they literally have one set of robot arms on the back of the cart and the actual set of robot arms on the front of the cart. And there's a guy standing behind the cart moving the back set of arms around, doing the task with the front set of arms while the camera watches it. And so by doing that, then they build up these training sets. But the Genesis simulator system allows you to, so instead of having to collect all of that data manually, the way that Aloha was doing it, you want to use a simulator if you possibly can, because you can run that much lower cost. You don't have to have the actual hardware. You can get human beings to just basically play a video game and record the video game. You would use that as the thing. But the problem with that is that, simulations are doomed to succeed, meaning that, it works in the simulator, but that doesn't necessarily work in the real world. And so you have to keep tweaking the simulator to make it match reality closer and closer, and you reach a computational limit there where it just doesn't work. What they found out is that if you train a neural network to be the physics simulator, then you can effectively continue to tweak it to be more and more and more and more like reality, because you just backpropagate and train the neural network to match what happened in reality. So now you have a situation where you can do, 100 or 1,000 training sessions with the robot in the simulator, and then run one of those in the real world, look at what the differences were in the outcome, update your simulator, and then continue to use the simulator to train the robot. So that is, like you can see the result from Unitree. It's mind blowing.
Yeah. I'd like to just interject one more plug. So the Silicon Forest conference is happening in Portland on Saturday next week, the 25th, and my company will be there, Rose City Robotics. We've got the Aloha robot. It's all open source hardware and software. So we have one, and it will be there. We'll just, if you want to see it and you want to drive down to Portland or from wherever you are, that's where we'll be. I'll put a link for the Silicon Forest conference in the chat.
Perfect. Yeah, thank you. Please do. All right. So again, we're going to start a little bit early just so that we have enough time for questions in between presenters, because I don't know, we have roughly an hour worth and we only have an hour to present. So if they're a little early, you can ask questions. I'm going to start with Bob's first, just because his is a video, which is great. It's very kind of him to do. He sent it to me last night. I only played the first like 30 seconds of this. I have one tiny little interjection. I'm going to hit play on this video. I'm going to pause it to make sure that you guys can hear the audio. Pretty sure I shared the audio right, but just to make sure. And I have one tiny other little interjection that's a meme just because it was funny and who I am. So I'm going to start with hitting play here, and then just I'll pause it and you guys can let me know if you hear it. I think it's a little quiet. You might have to turn up the volume. It's turned up as loud as it can be on my side. So if you can't hear it well, I'm sorry, you're going to turn up your volume locally.
Hey, good morning, everyone. I'm here to talk about my
Could you hear him okay?
Yeah, you're fine.
Okay, cool.
updates that I did for Robo-Magellan this past year, during and then ran in October. Just as a refresher, my Robo-Magellan, a lot of the work that I'd done the previous year was around better cone detection, and I spent a lot.
Okay, I promise this is the only other one I have planned to interject, but because I am who I am, and there was nobody more mature to present this today, I have this little screen gem because it's from The Wedding Singer, which is one of my favorites.
They were cones.
All right, so I'm done. I apologize. I'm done. But but if you've ever seen the video, it was hilarious, or the movie, The Wedding Singer, very good movie. Okay, I'll continue.
Of time learning about and developing a machine learning model. You can learn all about it from the, I guess it was the December 2023 SRS meeting. It's on YouTube. And that was a talk that I gave that I tried to go into all the details of how I built the model, what I learned, things that you might find if you were trying to replicate my results. There was some images that I used. I was collecting different images for training purposes. This is how the labeling works for that. So you basically are coloring in the pixels of objects of interest. There's other ways to do it. You can do bounding boxes. There are some approaches these days that don't even require labeling explicitly. This is a sample output. This was from, I guess, September 2023 from the robot. And I record some metadata whenever I take an image. with prediction. So the confidence is really literally the confidence of a model detecting something. So 91.6%. Confident. The time is in milliseconds, so 1600. That was one of the downsides. That's a big thing I want to talk about today. So it ran well enough, and I would say it ran well enough to be almost practical. It was running on a Raspberry Pi 4. The model was about 6.2 megabytes of data of a big, sort of neural network. And as I said before, the prediction takes about 1.6 seconds, which isn't real time. So what I did is I essentially developed a strategy where the robot kind of drives itself into the area of the cone. So this is the robot's coming to the end of its initial navigation phase. This is all GPS based. So it's essentially trying to steer more or less in the neighborhood of where the cone is, according to GPS waypoints. And this is not a bad distance. This is actually, given GPS inaccuracies and all the trees, this was actually pretty good. So what it's doing now, or what it had been doing, is it ran a prediction, again, kind of 1.6 seconds per frame. So it runs rather slowly. And what it's trying to do is line itself up with the cone. So it did the initial prediction, saw the cone on the left of the robot, backed itself up to get a better kind of head-on view of it. And now the camera on the front there is pivoting around looking for the cone again. So again, it's kind of 1.6 seconds. So it's not bad. The strategy is kind of take a picture, process it, and then kind of do some path planning based on where it thought it was. So you'll see it's going to kind of turn towards it a little bit better here. And it's going to continue kind of moving up the hill. The general idea here is that it's kind of, again, it does a little bit of movement, then stops, does some more image predictions to find the cone again, and then it continues to kind of do that and stop and predict and stop and predict, and sort of it's this kind of very jittery thing. It was reasonably successful, and this is a good example of where it was successful to find the cone, hit the cone. It uses a bumper to find the cone. The problem with this is that it wasn't always that accurate. There's plenty of examples where that last kind of few feet, maybe a meter or so, it wasn't accurate enough in knowing where the cone was, or it steered off too far to the left or too far to the right and would sometimes miss it. So that was something I really wanted to kind of clean up here and kind of move the whole idea forward a bit. So for 2024, my ambition was to figure out how to do real-time cone detection. And that meant speeding up the processing of the machine learning model, and then try to incorporate that into real-time steering. So it literally was using it to kind of steer left and right and keep moving forward, so you didn't have to stop and move and all that. And I mean, real-time detection is absolutely achievable. And so I started with the assumption that it was achievable. I started looking at hardware solutions. I tried using an NVIDIA Jetson Orin Nano. It's quite an expensive platform. It does work really well. The real issues with that is I had a hard time kind of getting it to integrate with the rest of the robot software stack. I also found that the Jetson kind of development environment is really tough to work with as a hobbyist. And I never did, but I'm not even sure how you get it to run off a battery, to be honest. I had the same problem with the Raspberry Pi 5. So the Pi 5 came out. It cuts the prediction time down by about a third using the same model. It's great, but I couldn't get it to work reliably on battery power. It could boot up on battery, and then anytime you're doing stuff, either intense file system activity or intense CPU activity, it would just brown out and kind of reboot itself, and that was never going to work. There's probably good solutions for that. I kind of gave up rather rapidly. I also looked really briefly at some of these kind of small little dedicated widgets. The Grow Vision AI module V2 is a popular one. It's from Seed Studio. It didn't really fit in with how I had built the robot, in the sense of the software stack and having a whole separate module, and then have to find some way to communicate out with with the rest of my stack and so I just gave up on it pretty quickly. I also found that the hardware that it's using, the NPU, wasn't really working well. It didn't seem to be compatible with the kind of models I've been generating from the YOLO model. So I looked at other options. So clearly, if you had the hardware and a small enough, efficient enough model, you could actually get it to run in real time. So I started looking at how the YOLO stuff works. The good news about the Ultralytics package is it's completely open source. You can go read out how everything works. And when they trained up the YOLO models, you can actually go find the source and the parameters that they use for training. And I found this bit of data, this bit of information. So the rows here start with a column on the far left side, N and S and M and L and X. Those correspond to the size and therefore quote unquote sophistication of the model, which is inversely proportional to the performance of the model, particularly on kind of like a Raspberry Pi 4. So the N variant was the smallest one. It was about 6.2 megabytes, as I said before. And it ran in 1.6 seconds. When I retrained it, that particular model parameter set to do cones, it still stays the same, and it gives you the same more or less performance. But I started wondering if it was going to be if there was some ability to kind of rethink the training parameters and get better performance out of it. And so these definitions at the bottom, the depth and width and max channels, was kind of some stuff I found digging deeply into the Ultralytics project itself. And I thought that last line was the one that was really kind of gave me some hope. Adjusting these parameters can help you find a balance between speed, accuracy, and model size that suits your specific case. So this is from a tool called Comet ML. It's a graphing kind of thing that gives you metrics out of your training. It's comet.com, by the way, and it dovetails really well with the Ultralytics toolchain, where you can basically just do training, and it will automatically upload the kind of information, the metadata about the training process in real time, and you can kind of see how it goes. And so this was a particular metric I was trying to focus on, and the 0.99 kind of is more or less an accuracy. So the parameters are at the bottom of the image. That was 2023. I spent a lot of time playing with parameters. I also found that adjusting the size of images, the size of images used for training, made a huge difference in the performance of the model. Obviously, you can't go too small. You're going to lose detail in the image. And going too large just means it's more data to crunch through and building out the network. And I found kind of a nice compromise with these parameters and 200 pixel image width. And as far as I was concerned, the image accuracy was still very, very high and good enough for me. And the good news is that that improved the performance. That improved the performance down to about 350 milliseconds per image. So you kind of see the camera moves a little faster. There's still a delay as I'm waiting for the servo to move, so I can actually be doing the image prediction faster, but I have to wait for the servo to move. And this is, you're going to see the robot is intentionally aimed not at the cone, and it's having to steer towards the cone, and it makes a last minute correction there as it wants to actually go dead center on the cone. So I was really happy with these results. This was kind of the culmination of the effort for this year, was to try to get to real-time detection and put that into the steering loop. So once I'd spotted the cone, I could actually drive directly towards it. And it was always the hope that, as you saw in that little video clip, hit exactly the center of the cone. And so it came on to the results, and this is kind of a summary slide. So cone detection worked really well. Real-time steering, kind of putting the image prediction in the loop of steering worked great. But for me, Robo-Magellan didn't go at all well. And it wasn't related to the cone detection. It was I had some really bad electrical problems on the robot. It meant the steering and speed control were not working correctly. In fact, they were working kind of almost randomly. Probably some people might remember seeing that there. It was just it just didn't work well, and so the whole thing was kind of a bit of a failure to compete. But it was fun to learn, and I really enjoyed kind of doing the work to kind of improve this. I think that I could get the prediction to run even faster, but I don't think I need to. And that's about it. So thank you for your time.
Great.
I wish he was here
Um,
so we could ask questions.
Yeah, I hear you. He'll be back next time for sure. I know that one thing that I can attest to it, find it interesting. Of course, you know, we asked a lot of questions when we were there, thankfully, but because it's a very interesting robot that he has. It was you know, the interesting part about the Raspberry Pi's sensitivity to power, and I'm sure the Jetson Nano is the same, but I mean, yeah, I guess they just don't make power supplies they used to for good reasons because they're more efficient now. But you know, it makes I have a Raspberry Pi 4 on my robot, and if anything happens that takes a solid power drop, there's a drop in power on the buses. And so you know, I'm actually I'll get one of those low voltage alerts on the Raspberry Pi. It actually does alert you if you're running Raspbian anyways. And I'm starting to consider like actually having to put like some sort of small capacitor bank on my power just to clean it up a little bit. I haven't gone there yet.
100%.
Yeah.
I've seen, just so you know, I've seen that a lot working with, because I did a lot of stuff with very large 3D printers. The electronics for stepper motor drivers are notoriously bad for spikes on power lines. And you know, like for a small 3D printer, it's not a big deal. But when you start scaling things up with, you know, really large stepper motors like NEMA 34s and, you know, like hundreds of watts of power going through the driver, you can't have like any combination of power supply between those two. And so we ended up like completely separating the power supply. And at least at one point, keeping in mind that this is like plugged into mains power, right? And like completely isolated. And we were having so many problems with even mains power getting pulled down.
Wow.
That honestly, that was mostly from when the extruder would kick in. That we actually ended up putting a battery on the logic power supply, just to, you know, batteries are the ultimate capacitors, I guess. So yeah,
that's fair. Yeah, I can appreciate that. I would have thought that the large amount of acceleration, you know, it's essentially a direct short when you're starting to power up any, you know, any motor. But you
100%.
think those 34s would draw a ton of power just on that initial acceleration. I could definitely see that causing you some big issues because those things rip. Yeah, we'll move on from here. We'll have to shave our questions for him for the next time, but I will turn it over to Donna. Do you want to go next?
Okay, sure, Chaz. Thanks.
Okay.
So I'll go ahead and get stuff set up here for share screen and whatnot. Okay.
Yeah, no, sounds great.
Okay, let's see. So can everyone see my screen, my presentation screen? Okay.
Yep.
Yes.
Okay, cool. All right. Let's see here. Okay. Thanks, Chaz, for the brief introduction and allowance for me to speak today at the Builders Roundtable. For those of you who aren't familiar with me, I have been a longtime SRS member since about mid-1990s, and I am currently the web admin for the robothon.org website. And I'm also an active member on the events planning committee for the SRS. In addition to that, I have been building contest entry robots for a number of years. And I competed at the October 12th last year mini Robothon contest day. So I will be presenting my learnings and my next step plans regarding robots at today's presentation. So I only competed in one contest in October, and that was mini sumo. But I had two different robots that I competed with that day, Smash It and Snoopy. And here is the front face view of both of those robots. The one on our left is Smash It. The one on the right is Snoopy. And these were built from I have no idea if Parallax still sells this particular kit, but this was built from a mini sumo Parallax, mini sumo competition Parallax kit, where literally everything except for the ping sensor that you see in front of you is included in the kit. So wheels, motors, servo motors, and the whole platform, and also basic Stamp 2 controller boards, along with a whole selection of sensors are included in this kit. So it's a great starter kit for anyone, especially starting out in mini sumo, that I can suggest, if that kit is still available. And the next thing I want to do is talk about, review with you what my expectations and what I had planned and what I did regarding Smash It and Snoopy. So the night before the contest, I thought, well, what are my expectations for tomorrow's event? And I wish I had had time, but I knew it wasn't possible to beat the Thin Man. More on the Thin Man later. The trouble was I only had minimal time to do any upgrades, to do any tuning for either of these robots. But I really wasn't too concerned, because these have been long standing over multiple years, usable, very competition ready robots. So I really wasn't too worried about that. But one of the upgrades that I did have time to do was to add in one of the that I had never tried before. There were a pair of opponent detector modules in each kit that was supplied, and I had never experimented with them before. So I went ahead and coded them up, added them to both robots, and I ended up on competition day having poor results. On one of the robots, one of the LEDs literally broke off, and so that kind of ruined that experiment. And how did both of them perform on that day? Well, Smash It was dead on arrival. Of course, I wasn't expecting this, and I still haven't to this day been able to debug what the root cause really was in that issue. And so that's unless there were just some gremlins at work, which is always possible. But at the same time, I was very pleased with how Snoopy did. He placed third out of 6 entries that day, with only the Thin Man coming in at number 1 and Dozer at number 2. So I was very, very pleased with that. And it qualified as prize material that day. So that was a big win-win for me. A summary of my learning points. Point number 1, it's a great general policy for all of us building robots on competition day, is that on the morning of the competition, that we should be testing our functions of the robots, actually putting them on the platform, on the course, and actually changing out the batteries, doing rebooting the machines, and actually doing a physical test. This will help to avoid dead on arrival issues. Point number 2, it's a good idea to design sensor choices and the way that they're mounted to fit the particular robot environment, especially for high impact and high vibration kind of environments and robots, for instance, sumo and outdoor rovers. And this is a great design choice to always follow. Number 3, avoid procrastination. That was a problem for me this last year. And always start your builds and your redesigns, your tweaks early, because it always takes longer than what you plan. Number 4, this is something I've been wanting to add to my robot designs for a number of years. And that's the idea of building in a test suite, a custom test suite for each robot to simulate a power on self-test for the code and for a UI on the robot. And this will help to identify any subsystem failures. And this is a good general practice, I think, for all of us builders to start incorporating or to consider incorporating in all of our designs. The idea here is that on a routine basis, especially say a week or so before a competition, that you run your robots through this test suite to identify issues ahead of time to allow for recovery, for a decent recovery window. Number 5, set your build goals and expectations early. This way, I know for myself, with expectations, perhaps next year I can beat out the Thin Man in mini sumo and also achieve a lot of my other goals for other contests that I want to achieve. The whole idea about goal building and setting your own expectations, aspirations is so important for everything that we do in life. And that includes with robot building. Point number 6, these events like mini Robothon in October are always fun to attend. The learning and the socializing are always stellar. I always enjoy that aspect. But in reflecting back for last October, for me, the real enjoyment comes from competing. And that's something that I want to aspire and empower all of you to consider within our robotics community to be doing more competing. So my plans for next steps, specific, first of all, to Smash It and Snoopy. I want to add in more, I want to swap out the current servos and put in more powerful ones. That way that will increase the pushability of the designs, etc. I want to add more opponent detectors. Of course, everything is out with those parallax kit supplied detectors I was mentioning, but I want to include them on the sides and in the rear, in addition to new ones in the front. That will help with the overall design. I want to add a tilt sensor and motors stall sensor to note, for instance, when the robot is stuck on the opponent's blade, which is a common design for a robot in sumo, to a big goal opponent and then pushing your opponent out of the ring technique is to incorporate a front blade that forces your opponent to stay on that blade and then be able to push them out of the ring more easily. I want to improve the P-Basic code, the basic stamp 2 code base for each to improve sensor response times within the main loop and to be more aggressive with opponent attack strategies. And in summary of my 2 robots, time and time again, this past year, was very obvious that Snoopy is shown to be the better design. And I will be spending more time on Snoopy versus Smash It in the preceding, in the upcoming upcoming cycle. And other builds that I want to do, other contests, other learning opportunities that I want to explore for myself and be able to build robots and compete in the various contests. I want to focus a lot on new learnings, creativity, with this hobby that I love, and to ultimately be able to build out individual plug and play type subsystems. This will allow me to save money on buying additional duplicate parts. It will also allow for development of what I call hardware and software recipes, where you can individualize an individual subsystem that can then be placed into a whole slew of different robot designs that can integrate that same subsystem. So I love the idea of a plug and play type environment for building. So I will be striving to achieve that. I want to build at least one additional mini sumo design utilizing finite state machine architecture. And also for this new build, I want to include low mount opponent detection in the front to be able to locate the thin man. I also want to design and build at least one new line maze robot that will be incorporating a more powerful traditional computer science maze solving algorithm. I already have an existing line maze design, but I want to add a new one. And also I want to concentrate a lot on the build challenges, like from build challenge number 2 onward, and for the idea about developing more sophisticated outdoor rover type designs. I also want to build a Robo-Magellan. This is a more or less the capstone project of this prioritized list that you see in front of you. And that would be a great achievement level for me personally. If I can complete to a decent level competition robot in Robo-Magellan. And that's going to be a wrap, and I will open up the floor for questions and for feedback.
Can you show a picture of Snoopy again?
Okay, sure. Let's see. Oh, well, maybe I can. I'll get that on the screen here in just a second.
I was just kind of curious to see what the difference was between, to have a visual reminder of what the difference was between Smash and Snoopy.
Okay, so here's the picture again. So they're designed entirely different. Smash It, that is again on the left, really has no opponent detection to it, other than that defunct opponent detection that I did try. But it was in previous years very powerful. It had, even though they were identical servos across both robots, Smash It was a more powerful. It had better pushability than what Snoopy has had. Again, I couldn't prove that out this in October because of the dead on arrival issue. But that's one great big difference between the two robots. What I like about Snoopy is the opponent detection that the primary one is to do with a parallax ping sensor that is facing out towards us. And that is an extremely reliable, at least indoors, extremely reliable, easy to program, easy to interface sensor for such environments. And due to size, weight considerations, all that kind of thing with Mini Sumo, it can be kind of tough to do a bunch of sensor additions. And so you have to be very clever, very strategic about what you do, where you put sensors, which ones that you choose, etc. along with the overall coding architecture, software architecture that you employ. So that's the main difference between the two robot designs. Does that answer the question?
Yeah, I think so. Just a real quick little personal experience. Those ping detectors are very good until you happen to end up in a classroom at UCSD Extension with automatic fluorescent lights, which come on automatically when you walk into the room because they happen to use ping sensors to to tell whether or not somebody's in the room. So you walk in and the entire room is flooded with that same frequency of sound from the one that's built in the lights. I was teaching a class there, and none of our robots would work until we went out into the hall because the ping sensors in the room. But the question I guess I have is, would you say that the inclusion of the ping sensor and that is that what makes Snoopy a better choice for you? And would you say that that's an example of brains over brawn winning?
Probably brain over brawn winning. But as I said already, that the ping, I think, is for mini sumo at least, or maybe even for 3 kilogram sumo, any level of indoor based sumo contest, I feel that the ping sensor is a great choice. Number one, because of the distance detection that is automatically included with that particular sensor. It seems to, across varied types of natural and man-made lighting situations, it does appear to work well. When we used to be over in the Seattle Center, that room, that the Armory building where we used to hold our indoor contests, occasionally with the way that the skylights were or are in that building, on real sunny days, occasionally the ping sensor would behave erratically and throw everything off with the robot. But that seemed to be few and far between as far as angling of that natural light and variabilities that way. But in general, for a general rule of thumb, I would say that yes, that the ping provides a brain over brawn kind of great solution for that contest.
Awesome. Thank you, Donna. We're at 20 minutes and we're going to do 2 more. We're going to squeeze. John, do you want to go next or do you want me to go next?
So I can go next.
If anybody has more questions for Donna, maybe shoot them into the chat too. Just, I didn't want to cut anybody off, but so we can get the other 2 then. Thank you, Donna, again.
Maybe I can go next here. Let's see if I can find out what I'm doing here. Okay, this is interesting. I don't know if it's going to work or not. Oh. I have a settings here I have to get through. Okay, I don't know what's going on here. I've got these like little triangle signs. It's not letting me share.
That's weird. So I think when you on the share button, there's like a little up arrow, and that's where you can like do the settings for like who can share. I guess that's for me, not you. and it says everybody. Well, Donna just went. But then when you hit the
Yeah.
button itself, I think you select your screen, and then you can choose to share sound and also my video. If you want to take a look at it, I can do mine first, and then just.
Oh,
get back
okay.
to you.
Yeah. Okay.
Is
Yeah,
that
that'd be
okay?
great. Yeah.
Okay.
Thanks.
Yeah, there's no difference between me and you, I think. So I will share. I'll just do mine then real quick. Share sound, I think. And then every single time it goes and hides like all of the show meeting. There we go. All right. Again, my name's Chas Ihler. I started competing in 2014, I think it was. I'm not a long time now. I think I signed up for the Seattle Robotics Society because you could sign up at one time in the 90s or something like that. But I never attended any of the meetings because I lived somewhere else. I grew up here, but when I was in the Air Force, I lived in South Dakota. So I think I just watched the video channel and that sort of thing. Anyways, the great, unfortunately late Mark Kenworthy designed the PopCan challenge. And he used to come to the robotics meetings that we had up north, and he asked me if I was interested in starting off this competition with him, and that's what got me into competition robots. I think I started doing robots just because I felt electronics was my hobby, is my hobby still. And it's one thing that you can do with electronics, and it pushes me every single year to like learn something new, right? I've learned like a couple of years ago CAD and 3D printing and laser cutting, and every year I just add something else. And certainly rebuilt a lot of robots, but it was all in the effort to use it as like a way for me to push myself to learn more, and also to yeah, I mean, every single year I'm like decide to add something more. So I'm gonna go through kind of like, you know, what I did this last year, and then I'll go through the other robots, kind of the main idea of what I needed to do and some ideas, and then finally kind of what I'm working on for next year, what the big changes or what I needed to work on. So the competitions I attended this last year, we had in Lake Forest Park at the third place Commons, there was a PopCan challenge. It's a single event. I don't think it's happening this year, but we are talking about in the Robothon, like Seattle Robotics Society hosting something. Potentially, it's just on the maybe list. We did that last year in February. I competed with 2 robots. I don't have the pictures of both of them because I couldn't find one easily. I'll show photos of the other robots here and then in the next slide. But I had 2 robots, PopCan, PopBot 04, which was, I think it was like the last competition we did in the Armory. That it was its 4th year. So yeah, it's 2018 if I did the math right, I think, or 2019, whatever the last one we did. I think it was 2019. And then PopBot 08, which was a new robot. And in true spirit of my robots, I'm like, Donna, that one was DOA, so it didn't do anything, but PopBot 04 ran. And I use that one because it's, well, you'll see in another slide. It's just a reliable robot chassis. It's fun to show kids and stuff like that. So it doesn't do everything, but it does enough. And then early summer last year, we did the indoor event at First in Kent. I brought PopBot 04. I did not have time to work on 08 just because I had other priorities for robotics, and I really wanted to get my build challenges robot complete because, like Donna, I think they're very interesting. I think they're fun to compete at. So I reused PopBot 04 because it's very flexible to add on to it. So I mean, it's a really easy build challenge. It's a nice entry level thing. And I competed in that one and did okay. I don't remember. I think it was first place. Doesn't matter though. It's all about just the fun of showing up. Build challenges 2. I didn't have a name for the robot because I had a robot chassis that died the night before. That's always a good one. It's fun to bring them anyways, just to show people what you're doing. Even if you have one that's dead, it doesn't matter. Like, you can show people what you're working on. There's always a ton of questions. Like, I mean, half the time you're trying to get away from people because there's so many questions. But that's okay. That's like all the fun of is showing off what you're working on. And so, like, even if it's dead, bring your robot, test some sensors, make sure it fits where you think it's going to fit, that sort of thing. And then last summer, We had the SRS Robo-Magellan Plus, I think it was called. I don't remember the exact name, but something like that. I did build challenges 1 with PopBot04 again. I did build challenges 1 with 04 because this year we did it on the pavement, so the grass, and 04 does not run on grass. That's why I built Electric Mayhem 0.2. I had a 01, but it did not work out very well. So 02, which is technically number 2. I don't know why I start with 0, probably because they just don't do the complete competition. And then I also completed it in the build challenges 3 with Electric Mayhem, which was a 02. It kind of sort of not really did it, but it competed anyways. And then I am going to talk about mostly focusing on Electric Mayhem because it's the robot chassis that I'm going to bring forward to Robo-Magellan hopefully this year. That's what I'm working on. And then I also competed in mini sumo with Whatnot. My daughter technically had one there. I won't talk about that. And I'm not going to talk about Whatnot. It was a Pololu robot. I programmed it while I was on an airplane. And it did not win at all, not even a little bit. And that's okay. It's no big deal. Again, it's all about the fun of just showing up and hanging out with people that are like doing the same thing. So on the left-hand side, this left-hand photo, this was my setup at the summer event, even though it doesn't look very summery out there, or the late summer event. This robot in teal on the bottom with the scooter wheels, and it's all kind of tealish. I think it's technically called seafoam. That's all 3D printed. That is my Electric Mayhem robot. The robot on top of the black case, the carrying case, that's the sorry, it's probably as big as I can get it on the screen. That is PopBot 0.4, and then there's some other bits and pieces. I always bring a fair amount of stuff because I found every single year something breaks and I have to fix it. And I always bring extras because even every once in a while you can help somebody out. I think John once had to solder a connector on his robot. And then on the right-hand side of the screen is I'm on the right, Greg is in the middle, and then John is on the left, at least how I can see it. With our robots at the that's the PopCan challenge at first in Kent. So that was the first part of the season. That was the early summer one. Again, PopBot 04 there and the white, and not even the robot I'm going to talk about, but that's what we did last year. So I'm going to talk about Electric Mayhem and the lessons learned, and I'll tell you, like, I felt like I did a really good job. I'll say it again in a second, but I felt like it was really important to set goals to Donna's portion, to make these successful, to set goals, set milestones, and you know, like set dates for yourself. Like, I got to get this done. And the whole point of for me for competing is setting dates so that I can show up on time and I have a completed product. And the fact that I compete is the only reason I finish these robots, because I have a lot of projects I've never completed because I didn't really have a time frame, like a point that I had to get completed. I procrastinate, or I learn what I wanted to learn out of it and just kind of like, that's done. I just, you know, it was the journey that was interesting, not the final product. But you know, lesson learned for me here. I had some problems with this robot where I couldn't understand what was going on when it was actually happening. So I'm looking at my robot and I'm like, what in the world is going on, right? And understanding what's happening when you're looking at it, when it's actually acting up or not doing what you expect it to do, and understanding that in a timely manner is key to correcting the issue in code between events, because you got 3 tries at these events, right? At least the ones for, yeah, most of them. So, you know, I got a little short circuit there, need input, right? As a human, I need input. I need to understand what in the world is going on in this robot. I'll show that to you in a second here. So here's where it's going, and I'm gonna see if I can play this clip. This is 1.5 minutes on the money, so not too long. This is build challenges 2. It's go out and come back, and whoever comes back closest to their starting point wins. So the way there isn't super eventful.
I definitely thought this thing was going to be a lot more squirrely. When it's in the grass, it definitely is because it has this like torque mode, and it'll drop more power into one of the motors, and she kind of keeps a bearing, but definitely not as doing really well here. I'm short. My metric conversion, my encoders. I had to give me a penalty for that one. I can.
Okay, that's about 2 feet short.
Yeah. I'll add a couple more centimeters on.
It does a good job.
Tracking.
When it starts out, it does that kind of
the wobble thing.
And then,
Yeah. Uh-oh.
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 Uh-oh. It
Uh-oh.
has an attraction for grass.
It does have an. Uh-oh.
There seems to be a deviation here, Chaz.
Yeah. Where's it going?
So I didn't know where it was going. It's almost done. But
Yeah.
and the problem is, like, on this robot here, I've got this little tiny display right there that I can start it on. It's a little display right under the play symbol. And it's got an LED lit knob, which gives me like some indicators, like a bump or an e-stop or something like that happen. But it doesn't give me a lot of information about what the robot thinks is going on. And and even the little display will tell you like instantaneous, but you know, it's really hard to read that display while it's going. You don't want to get too close. So a lot of my problems were I wasn't getting information to understand what is going on with the robot. Is it in the right state? You know, in mine, it's all state-based and it has a bunch of different like submissions, if you will. Like, is it in the right mission? Like, did it skip one? What bearing does it think it's going? Or what's its target bearing? Did that move somehow? Did I mess that up? Did I screw up a variable? What's the target and the distance to the target? And then what are my inputs? My inputs like time of flight sensors, IMUs, GPS, whatever your inputs are. And I did have like a tablet, but the problem was I'm holding this like RC radio that's in my actual video, and the RC is fine because I needed it for a dead man switch. It's a requirement of the competition, so it makes sense, right? So I have a dead man switch. So if something happens, I let off the trigger. The RC signal, you know, sends it to make the robot stop so it doesn't run off and, you know, hunt down little kids or something like that. And I do log, but logging to an SD card is time consuming. Like, you can look at it later, but looking at it at the event when you have maybe 15 minutes to go again, and it doesn't really correspond to what you're looking at. So you have to like just parse all this data. It's not really practical to look at that in like the 15 minutes that you have, or you're supposed to have 30, but look at that and then make the changes you need to make. So having like an actual like on the fly kind of information is very important to have like while it's running, just to understand what your robot's doing. And it doesn't mean it isn't even particularly pertinent to competition day, like just when you're testing it even. So my suggestion is design with the day the day of changes in mind, right? So I say here, I was reading for you, right? I know you can read, but I'm going to say it anyways. So dedicate a significant amount of time of your planning to developing easily modifiable things like conversion tables and metric conversion, you know, whatever you're doing, you know, the conversion from your encoders to something logical, like, you know, understanding like how many inches your robot has gone through, and making those, because they're really easy, like, oh, I'm short 14 inches, right? Well, you don't want to figure out that's 14,326 ticks or something like that. PID parameters, right? We were just talking about that earlier, actually. You know, if you have PID loop, you need to be able to edit those. You saw my robot had a bit of wobble, that was PID parameters. Waypoint values, etc. They all have to be pretty quick to you don't want to spend like all the time you have to just change your waypoints. John has a great system for that. I'm super jealous. I'm not going to get there something like that this year. Develop a log report. I mean, from design, develop a way to log. That means if it's broadcasting like, you know, waypoints or whatever the status is, terminal print status, kind of like what Donna was talking about. She mentioned that. having some sort of user interface. I think, I've seen people with like, sending data over and having dashboards on a monitor so they can watch them. And of course, dummy lights for the big obvious stuff like, oh, the bumper hit. So like a light turns red, something very obvious from across, a couple feet that you can see. Well, I mean, this is kind of a no-brainer, but I am guilty. Document your code, your objects, your procedures so that you can find it quickly. Because you got 15 minutes. If you're sitting at home eating the Doritos or whatever, no big deal, right? You're not under like this time crunch to get everything done. So, just have all your variables up on top if your program allows for it, and all in really easy to find stuff, all documented out. Be consistent with your naming protocol format. I've not always been that way. Like I'm programming it this way this month, and like 3 months later, I'm doing another program for another controller and I'm changing names because I'm just making them up as I go. Terrible idea. If you're using like C, or whatever, using header files so that you're sharing the same sorts of things like CAN addresses and that sort of stuff. And my number one suggestion is build a minimal viable robot per day for testing, right? Don't expect it to complete any part of the mission. Just your viable product, your goal at the end of the day is it can move forward and stop, whatever it's supposed to do. It doesn't have to do everything. Just the fact that you did it, you'll trust me, you'll feel so good about having that, and build against that. And then if we all have it, we're like, ooh, shiny thing, right? You get that scope creep in your robot. Add those scope milestones for once you finish that day of, like it can roll and it can stop, happy day. Now it can turn left, happy day, right? Just do that minimal viable like robot, and that is your goal. And then just build in all the little additions you want to do to the back end of your robot, or your timeline, because you don't want to be developing these like me and Donna doing stuff the night before. And I didn't this time. I actually had like a week and a half before the competition, and I did a bunch of ads to it. So there's that. Now, what am I gonna do next? I'm doing live monitoring this time. I did not have that last time. I kind of had something that didn't work out very well. It was with ESP32, and it was just like the static refresh page. It's like every 15 seconds. It's totally pointless. It was basically not worth anything. I mean, I got a little bit from it, but I need to do live monitoring, and I'm talking about like WebSockets where it's like I see stuff, that's fairly live, like every whatever. It's only a second old or something like that at most. So I do have now a dedicated processor, which is just a Raspberry Pi 4, to parse the CAN messages. And I have been designing with all these things in TENS from lessons learned. I said debit connection. Sorry, that was me doing my PowerPoint last night, specifically for consumption during the for logging consumption, I guess is what I meant. I don't know where I was going with that word, but I have everything on CAN, so everything talks CAN. Doesn't have to be that way, it just is. My two motor drivers, I have two O-drive motor drivers. There are photos right there, they're S1s. I communicate CAN with them. Oh, I'm almost done, sorry guys, over. And then I have two RPi 20s, one for like things that pull very slow that I can't get around because that's the sensor, and one for like my main loop. And then I have the RPi that also has CAN. I dump that stuff into MQTT, pick it up in Node-RED, and then Node-RED has a dashboarding system in it for with this very easy to edit system where it can like pull these MQTT messages and go back and forth. So I don't have to do all the web development because that's not my forte. So live monitoring is a big win. It's something that I need so that I can identify like, why is it turning this wild right? I don't know. I don't remember why I did it. I think there was a problem with the IMU. I kind of figured it out day of. It kind of worked out, but I'm still not 100% sure. So with that, that is kind of like where I'm at, where I'm going. I guess I could say, is there any questions?
So how did you end up debugging any of these problems, or were you just not able to, basically?
I was not able to, right?
Okay.
I knew the code so I could guess, but like, why did it take off to the right? I still don't know for sure, because I don't have this. I didn't understand like what it thought its bearing was and what it believed its targeting bearing should be. And I needed to know what state it were, let's call it submission, right? I needed to know, like, right now it's in mission 14. Well, I know what it is because I programmed mission 14, right? And it's got like some parameters to go to bounce it to mission 15, if you will, or waypoint kind of things. But I didn't. And that was a big part of my problem. I needed to be able to do that. It's, when you're looking at it.
Yeah, that whole thing of getting information over a remote link is really difficult. I mean, I'm curious. I posted a thing about it in the chat. I'm just really curious if anybody else comes out with any other like solutions for it. One thing that I've actually seen done at a local group of kids who were doing FIRST robotics, they actually put a voice synthesizer, an amplifier, and a speaker on the robot, and it yells out what
it's doing.
What
awesome.
it's doing. The problem they've had with that is that sometimes they can't hear it because it's in the middle of like moving, and there's some clank or some other noise of it moving, and they're like, "What did it say? Did you hear it?"
I can appreciate that. Yeah,
But
mine has right now I have a hotspot and so I just connect with my phone, and because the Node-RED has dashboarding, I just connect with my phone and I can watch it on my phone. I actually use my phone for my eStop now too.
Okay. So that is a solution. You have a solution for it.
That is my solution. Yeah, it's just wireless to my phone. The Node-RED is a website that the Node-RED has a dashboard on it, so I can sit there and look at it, and it has built-in WebSocket. So like as soon as the MQTT value changes, when it picks it up off the CAN, I have live good data right on my phone. So it's pretty slick.
Sorry, I'm not sure how I missed that because I didn't.
Oh, no problem. I was just trying to finish up really quick because I'm kind of going over my time, and it's John's turn.
All right, sorry.
So I will demonstrate Node-RED if anybody's interested one of these days. It's pretty slick. It's very easy to program with.
I'm certainly interested.
I will put it on the to-do list. John, I'm sorry for going over. I'll definitely answer any questions in the chat or follow on sometime. Is John still here?
I'm going to see if I can share this time.
Yeah.
Good. Okay. Now it was a update on my Zoom, and I had to reset all the settings again. Okay. Can you guys see my screen here? No.
Yep, we're good. Yeah.
Oh, what the heck is this? Okay. I'm not sure what I'm sharing.
Yeah, we see SRS presentation January 2025 notes to share. I don't know if you're sharing the right page, but
nope, that's not one I want.
Okay.
I'm sorry. Let's see if I can
All right.
do this correctly here. Right. Would be this. Okay, that makes more sense.
That looks right.
Yep, sure. All right. So my plan this morning is to talk a little bit about the robot builds and the strategy for the given challenge, any lessons learned, and future improvements. So this year I had 2 robots, these 2 you see here, and I did 4 of the events. The first 2 build challenges and Robo-Magellan, and this mini sumo. The first robot I want to talk about is Audacity. I started building it in 2020, and you may have seen a presentation I did on that build. It started off as, it's called the Soppy Rover, and which is an open source designed by a guy in California, Roger Chang. And his was inspired by Jet Propulsion Laboratory, the open source rover, which was based on the Mars rover's Perseverance and Curiosity. Unfortunately, the SOPI R, I call it SOPI RMV, the Robo-Magellan variant, was really limited on its power and speed. So I made a whole bunch of modifications. I changed, and you can probably see the difference here. I got from 6 wheels to 4 wheels, 4-wheel drive. I just removed the bogie portion of the suspension, which allowed me to reduce some of the cost and weight, and also added the ability to move laterally. And you'll be able to see that in the first challenge. I changed to gear motors with encoders and upgraded the steering servos for more power and accuracy. The rover includes several sensors, but on this day, this Robothon, I really only use the encoders in the IMU. And let's see here. So in order for Audacity to meet the challenge, I have to send some information. So I have an Android app that you see on the right that connects Audacity to via Bluetooth. And then another remote controller on the left there, which acts as the emergency stop switch. It's a 915 megahertz radio. So let's see. So build challenge 1. The robot goal is to autonomously navigate around a square that's 15 feet on each side. So the strategy that Audacity uses is dead reckoning to navigate the course. First, I just point the robot in the first desired heading and then send 3 variables: the size of the square, the velocity, and then a start signal. The robot goes in a clockwise square pattern, navigates the corners by rotating the steering assemblies 90 degrees to the right of its previous heading. So I'll show you that here. I'll speed it up.
I love how it does those corners.
So it did the corners really well until it gets to this last one. And then, okay, I see, I'll speed it up here. And then it's, so it, for some reason, and I haven't figured it out what happened, but it's not going in the right heading. This is only using the encoders. It's not using the IMU. So, so my plan improvements for the next time is to go ahead and include that IMU data to make up for any error. And also, I'll add another function, because in the contest, the judges have the, I can tell you, okay, you have to make it left, right, clockwise or counterclockwise. You have to like have that option too, which I don't have yet. So that's the build challenge 1. And in build challenge 2, the robot's goal is to navigate to an orange cone. And you saw that with Chaz's. It set a predetermined distance. I don't remember what the distance was on the event. But the strategy for Audacity is to use dead reckoning and then also use, and along with the IMU. Let's see here. Oh, well, it's first, I have to find out what the first heading is. So I use my phone to get the first heading. A compass on my phone to kind of point it towards to the goal, and I use that for the first heading. And then I just add the speed and distance, and then the robot is supposed to actually turn when it gets there and go 180 degrees in the opposite direction. I'll show you what happened though. Let's see. And I have it going kind of slow, so I'm going to speed it up here too. So you can see when it gets to the other end. So when it gets to the other end, the distance is perfect. But it's like, I don't know, the gremlin, maybe I picked up something Chaz did because it's going in the same direction Chaz is
Yeah,
heading.
there was something under the ground or something.
But what I ended up doing the second time around was giving it a heading of both directions instead of using the programming to say turn 180 and go in the opposite direction. I just gave it a new heading, and that solved the issue when I did it the second time. So my lesson learned, I will do some more planning. That seems to be a common occurrence as far as robot builders here is they're not doing enough testing, and so more field testing, try and figure out what and troubleshoot that problem. That is build challenge 2. The Robo-Magellan goal is a little more complicated, well, a lot more complicated. Audacity does not have any vision or obstacle avoidance yet, so I just wanted to get as close to the goal cone as I could. The strategy is to navigate from the starting point to the goal using dead reckoning. Using the compass and a measuring wheel, I plotted the course using vectors to each waypoint and a series of them to reach the goal. And then I send those numbers to Audacity. You can see my little, what I sent here. You could see the heading, the distance, heading, distance, heading, distance. And I just send that to the robot. And so we'll see. I'll show you what happens though. Starts off pretty good, actually. I'll zip ahead a little bit. So the first turn does beautifully. That's the first turn. Then for some reason, it gets about halfway to the next turn and does that. It's going the right heading, but it didn't reach the actual waypoint yet. And it's heading to this gully, which probably in hindsight isn't a bad thing to happen because I got to actually observe it going over some rough terrain. I want to speed it up here again because it goes down in there and plows through there pretty good. As far as improvements go, obviously I need to figure out what problem happened as far as the navigation goes. So lots more testing to figure out what the cause is. But I did like to see that it was able to go through that that long grass. And let's see, that brings us to the next competition, which is the dozer. There's another robot that dozer kind of evolved from that had these Zumo tracks on them. And I ended up this year changing them to these silicone tires. And I'm very pleased with those. And plus I added this hard top. But the goal for the mini sumo is obviously to push the opponent off the doyo. And Dozer's strategy is to use a timer to switch between two modes. It has the rover mode and a scanning mode. So the rover mode, it just goes for a period of time randomly back and forth across. And then in scanning mode, it just rotates, looking and using a distance sensor that's actually in the belly of the robot, looking out through this hole here. So the opponent. And let me see here, my slide. Go to the next slide, maybe. There it goes. Okay. So let me show you what happened here when this is Thin Man here. This is Bob's Thin Man, that one that everybody wants to try and beat, that's been undefeated now for several years. I'm going to show you what happens in this battle here. So right here, I get a good shot at it, but it seems to not quite see it right. Got a good piece of it. And there, it got another, let me zoom ahead a little bit more. It had an opportunity to see it again there, but it didn't. And again there, and it didn't. And again there, and it didn't. So I don't know. I suspect maybe the daylight, the sunlight might have influenced the infrared sensors in there. Is a possibility. But here's what eventually happened. I got another problem when Thin Man is actually underneath the back of the robot. I no longer have any traction. It's actually lifted off, and I can't do anything about that. It just shovels me right off. So, 3 opportunities missed. And so my lesson learned, I think, on this one would be to maybe add some more tires, add another set of silicone tires or wheels on the front, and then have them driven by a belt-driven set. That would probably help being lifted from the back and give me some traction in that case. And then the next improvement would probably be to work on seeing and tracking the opponent. That seems to be the big problem on this one. And I suspect it might have been the sunlight, but I'm not positive. And I think that is everything, guys. Do you have any questions?
Seems like the theme here is getting debug data out.
for sure.
Yeah, I do have some LEDs on there. Unfortunately, now I have them all covered with the little hard top, but that would be one opportunity, is to actually get some LEDs up there so I can see what's going on. Because sometimes you can tell by the behavior of the robot, is it which mode it's in, but not always. It's actually came out of that mode or not.
I have a curious, John, on you actually send some information from your phone, or you're able to edit it or whatever it is for your Robo-Magellan, like for your
Mhm.
it's, I guess, bearing slash, yeah, that one, bearing slash
Mhm.
distance.
Yes.
What do those numbers, if you don't mind, just curious, what do those represent? I mean, it's 500, then like 1 through
Oh,
5 is maybe bearing. I'm just kind of curious what those
sure,
represent.
sure. So 5 is just happens to be the fifth function on the robot controller. And then the 0 is the row, and then the other 0 is the column. So we got row, column, row. So
Oh, I
what it
see.
does, it sends it to an array. So this is everything I'm sending to an array on Arduino.
Oh, I gotcha. That's interesting.
Mhm.
So the row and array are essentially waypoint data. Is that right?
Yes. Yeah. Well, it's just giving the heading and the distance to the waypoint. Yeah. So there's no GPS here. It's just
Yeah,
heading and distance.
dead reckoning distance. Yeah, I will
Yeah.
tell you that we spoke many words about how impressive it was that your robot made it through that gully. I thought for sure you were stuck, but it just powered right through without like it was nothing. It was very impressive.
John, what are you using as your communication method between your controller and your robot?
It's this is my cell phone screen here.
So is it Bluetooth?
Yes. I think I went into more detail on that Bluetooth ability on the previous presentation. I put some notes in the chat on the one where that presentation is, but I went into more detail on how I connected the Arduino to Bluetooth. Any more questions?
I have a lot, but they're kind of in depth and probably too much for this conversation. So sometime I'm gonna have to invite you out for a Walker Robots in the Park test session.
Yeah.
You're just a fun get together and go out to the park and do some roving around the grass. But I'll bug you then. All right. Well, I'm gonna stop the recording.